3, see if this is working. Please let this be working. Okay, this is my 18th attempt at the first video for Unit 2, Day 3. Here's hoping it all goes well. Alright, first off, when we're describing the shifts, here we have our parent function equals x squared, and we want to talk about what each one of these shifts represents. So we're going to go through from the last unit. Let's just talk about these individually. So you have a negative outside, and we have to think about horizontal versus vertical. Horizontal. Every single thing that's representing horizontal are inside parentheses. Every single thing. So no parentheses, vertical. No parentheses, vertical. Inside parentheses, horizontal. Outside of parentheses, or no parentheses, vertical. So the only one out of A through D, which is horizontal, is C. So that's your first thing. And if it's horizontal, you change something. So if it's adding and subtraction, what do we change? We change the sign. If it's multiplying, so we change it from addition to subtraction and whatnot. If it's multiplying or dividing, we do the opposite. So it's the inverse operations are what we're doing for horizontal. If it is outside and it's vertical, then you use that number. So 0.4, we're going to use 0.4. Positive 3, we're going to use positive 3. So if you can keep those two things straight, you'll be halfway through being able to recognize the shifts. So this is what we did last unit, so hopefully you've already written through there and see what you come about. So this is a horizontal reflection, or excuse me, I'm reading this right here. So it's a vertical reflection because there's no parentheses. So you don't have to say vertical, but let's just put it there so you have it. So vertical reflection, which means we're going up and down, which means we're reflecting over the x-axis. We forget that because we think, oh, vertical y. Well, yes, the y is what's moving, so it's reflecting over the x-axis. This is on the outside, so it's a vertical stretch or shrink. Because nothing changes, 0.4 would be less than 1, so that's a shrink. If it was on the inside, we would do the opposite, and it would be a stretch. So it's a vertical shrink of 0.4. You could change that to a fraction, which is 2/5. You might know that one. Inside, so now this is a horizontal, and it's left or right, so that's a translation of 2 to the right. What did we change? The sign. Negative would mean to the left, but because it's horizontal, we do the opposite, so we go to the right. This one's on the outside, so it's a vertical translation. Up 3. We use what's there because it's vertical. So we have all our different transformations, reflection, translations, and a shrink and a stretch is a dilation. Now we're going to apply that. So last unit, when I asked you to graph things, there was one, maybe two different shifts that were happening. We're going to plug them all in here, and we're going to go with it. So the first thing we're going to do is talk about our parent function. Okay, so we look all the way in here. If we strip everything but the variable and square roots, squares, whatever, that's our parent function. So this one is x squared. And we're going to show all of this work algebraically or by showing our tables and what is the change. So we're going to start with our parent function. We did this last unit. Starting with the parent function there, this one is negative 2 to 2. There's our turning point, so that's always in the center. And we're going to go through all of these shifts. So we have them all listed up here. So what do we have to do first? Well, first you have to do reflections and dilations, or shrinks and stretches. So what we have here is, let's start with the reflection. So we're going to reflect over the x-axis. What does that mean if you're reflecting over the x-axis? Hopefully you said that all that's changing is the y's. The y's become negative. So basically what we're going to do is come up with a table for the negative x squared. So all we do is change the y. So we keep our x's the same, just like back in geometry when you were doing transformations and you were doing the coordinates for the reflection over the x-axis. This is exactly what you're doing, but we're doing more than one point at a time. So the x's all stay the same and we negate the y's. So that's one part of our transformation. Now the next part is to do our dilation. We have to do it just like order of operations. You want to do your multiplication things first, and then we're going to do the adding and subtracting. So then we've got a dilation of 0.4. Now it's a vertical shrink up here, so that means what are we changing? The y's again. Actually, this would fit over here probably. So now our x, we're going from this table, we've already done some kind of change. We're going to multiply our y's by 0.4 because it is a vertical shrink. So this would be like f of x equals the negative 0.4x squared. We've already taken into account the negative, so we don't have to do anything. That's all done right here. We're going to multiply this part by 0.4. X's don't change yet. Nothing has happened horizontally, so nothing changes there. Negative 4 times 0.4 is 1.6, and then negative 0.4, and then 0, and the pattern continues. Now we're going to do our translation. We can do this, I'm going to do it separate to start with. So let's do the translation of, well, we'll go right in order here, right 2. So that means we're going to go 2, and I'm not going to go up or down. So now I need a new, so we're going to now do f of x, the negative equals negative 0.4, and then the x minus 2 squared. We've already taken care of all that with this table, so we're just going to take that. How do we do a translation? If we're going to go right 2, we're going to add 2 to all of our x values. Just like if you were plotting it, you go 1, 2 to your x, nothing to your y. So the y is going to stay the same. So up here we have negative 2 plus 2 is 0, negative 1 plus 2 is 1, and so on and so forth. 2 plus 2 is 4. Our y's did nothing in this translation. Now last but not least is the vertical translation of up 3. So this would be like f of x. We've already got all of this, negative 0.4 x minus 2 squared, but now we're adding the plus 3. So since we're using this table, the only thing we have to think about is that vertical shift right there. So x stays the same. In order to do a vertical translation, we add it to the y, 0, 1, 2, 3, 4. And then we add our 3. So 1.4, 2.6, 3, and then 2.6 and 1.4. This is the table we want. Going through all of the steps, showing your work. Now over here I've got the two graphs. I've got my original up here, and I didn't extend it for a reason here in a minute, and here's the translated one. After we transformed it, all of those different shifts. You can see that it's upside down because of our reflection. See, this is why I stopped here so you can see. This is our vertical stretch to begin with from our 5 points. It's from 0 to 4. We had a vertical shrink, and now those same 5 points are between 1.4 and 3. So from 0 to 4, you can now see that it was shrunk vertically over those 5 points. It's been moved to the right. So here's a point. If we go to the right, 1, 2, and then we go down 1, 2, what am I saying here? So we go to the right 2 and up 3 because it was flipped. That's why it will work. I don't have that one there. But from a flipped one, which would have been down here, then it goes to the right 3 or 2 and up 3, and there's our new points. You could graph each of these to see. Now, do you have to do all of these? No, we can combine them on tables that work the same. For example, These two right here could be done at the same time. If you multiply 4 by -1 or -0.4, it will take you all the way to the -1.6. So anything that's being multiplied by x or y, or both of them, it can be done at the same time, so you can combine those. Same with this. These two didn't interfere with each other at all. These two are here. You could add 2 to the x and add 3 to the y at the same time. So here is a shortened version of the same step. Here's the parent function. And here is our first part, or our dilations and our reflection. So -0.4 x squared. So I multiplied this not just by the negative, not just by the 0.4, but both of them. So you can see that this table right here is exactly the same as the third table after the reflection and the dilation right here. Then you can combine your two translations. So this would be, because I used this table, it has all of these, but it also has, oops, put the parentheses in the wrong spot, it also has the x minus 2 there, so that I went to the right, and then the up 3. So you can add those because they don't interfere with each other. So you can actually bring it down to 3, and that will work every time because all of your multiplication can be done on the first one, all of your adding and subtracting can be done on the second one, and that will shorten it right up for you. So let's take a look at this graph here and see what information we have. So let's talk about what the shifts are. First off, you have this 2 in front. So that 2 is representing of a vertical. It's on the outside of the parentheses, so that's how I know it's a vertical. We use that number, so 2 is bigger than 1, so that one's the stretch of 2 because nothing changes. Inside parentheses, so that 3 is telling us that it's now horizontal because it's inside parentheses. It is adding or subtracting, so that means it is a translation. And we have to switch something, so it's a positive 3, so we're going to subtract 3. Or go even better, let's say left 3. And then the minus 5, that's on the outside of the parentheses, so that's vertical. And it's a translation. And we use that sign, so we're going to go down 5. So those are the things that we're going to do from there. Now, let's go back to this real quick because I was writing it out here and then I stopped. So I was writing it from the right to the left for a reason, right? The last thing we did was the translation. We didn't go left to right in this one, and we went up 3. This is a composition of transformations. Do you remember that from geometry? Compositions of transformations? That's exactly what this is, and instead of using a triangle or a square, just random points, which we use in geometry, we're using a function, which is just a bunch of points. They're not points that are connected to make a nice square or triangle, but they're connected to make a function that's continuous. And so you go through the same process. That's why I wrote it right to left, is because you can see each individual one. So let's do the same thing with this one. What would we have to do first? Hopefully you see the multiplication. We would have to do a dilation of 2. And yes, this would be x or y, so it's for the y for this one because it's on the outside. Then we would do the translation. You can actually do those at the same time. We can go left 3 and down 5. There's no reflection here, so that's what we have to do first. Remember, compositions, we always work right to left. So why don't you pause it for a minute, go through. I'd like you to try to come up with your tables. You need to start with the parent function, then you're going to have to do the table for the dilation, and then you can do one table for the translation. You could do them separate if you wanted, but do them together and then check with mine. Okay, take a look at what I got. So parent function doesn't change. Multiplied the y's by 2 because it was a vertical stretch. So you can see that those numbers are now bigger. They still have a low value or minimum of 0, but this only goes to 4, that goes to 8. That's where that stretch is taking place. And then the last one, I did my subtraction of the x and subtraction of the y at the same time. And so since I'm going from here, that incorporates all of our shifts. That's what we're going to graph. Now if you take a look, I did graph them together. the first one, the dotted is the parent function, and here's just the dilation. So you can see that stretch there. These would be the same values. This one went from here all the way up to there. The 0 stayed the same. So the height from just those 5 points was 4, and now it's 8. So that is a vertical stretch. Then down here, here's the parent, that dotted one would be from the dilation, and then you can see I went left 3 and down 5 and have our remaining one. So this is our f of x right here. The other is just the work. Okay, we'll pick up the rest in the next video.